So we are again, we're going to be following the data science tutorial, the complete Python tutorial to learn data science from scratch. And so what we've done on class 10 was this exploratory analysis in Python using pandas. And today we're going to be talking about data managing in Python using pandas. And also as an extra, I can mention it right away, I recommend you to also see the next lecture. So from the Steven Schiena. So the previous lecture was, you've seen this week was on where to find the data. And here is the next one. This is called data cleaning, where he explains, he also, towards the end of the video, he also talks about the data managing, but he talks about the cleaning of a data from other perspectives, which we will not mention here in this tutorial. And so I think it might be quite useful to you to hear a bit more where the problems can occur, what one has to be careful about when they are dealing with data. All right. So, well, the data managing, data wrangling, what is that? Well, basically, when you get the raw data, right, somewhere you collect them or you download them from somewhere, you cannot just input them into the model right away. I mean, you can do it, but you might be very surprised what's going to be the outcome of it, because the data usually have some issues, and you have to basically, out of the data you've gotten from the raw data, you need to transform them into useful data. And we will talk about few techniques and a few things to do, so you do it in a correct way. And again, as we will see, for some things, I mean, this is really like the biggest part, I would say, of the and most important part of the data analysis, because if you don't do this properly, or if you do this completely wrong, then any model you're going to based on the data is not going to give you any good information. And so therefore you should spend a lot of time, and the data scientists spend lots of time with this data managing, wrangling, with processing the data and trying to look which is relevant, which is irrelevant. And there is not a single one good way how to deal. For example, we're going to be dealing with missing values, and so there are different ways how to deal with missing values, and based on how you're going to deal with them, that can help your model, or it can also totally destroy your model. So again, so pay a lot of attention to this step. It's basically the most important one in the whole process. So now maybe it's good if you kind of reread what we did, or watch the video what we did in the class 10, so you can freshen up, so you can remember. But so the short recap is, so we have this data set on the loans, and we want to create this loan prediction model, right? And so we have the following issues. So we have missing values in some variables, and also for some of them, for the applicant income and loan amount, we've seen some extreme values. So the so-called outliers, meaning the data that lie far away from the others. And so both of these things, they can severely, those are severe problems that they can, um, like I said, they can completely destroy your model, or they might give you the model based on this data might give you a very wrong conclusion. So this has to be dealt with, and yeah, let's go into that, because yeah, sometimes the easier you deal with it, worse the result probably you're gonna get. Also, some of the non-numerical fields, we did not check them very well, and so we should check whether how useful they are. Again, I mean, we have a big set of data, and we want to build this prediction model, and it's a good question to ask yourself: do all the data I have, are they really necessary? Do they have so much influence? So maybe maybe some of the columns in the data spreadsheet, logically in some way they have completely no connection with that. I mean, let's say there is a column that is contains a name of a pet, probably that has nothing to do with your ability to get or not get a loan in at least in this universe. In some other universe, maybe it could be very important, but hopefully in a normal bank universe, this has no influence on it. So you discard that right away, and you don't even include it in your model. I mean, as we will see that when you are creating the model, you don't want to include everything, because more different parameters you include, more difficult, more complex the model gets, harder the things get. So yeah, we should check that. And yeah, and so again, so for these techniques we're going to be talking about, there is a nice explanation here in this comprehensive guide to data exploration. All right. So let's start first with checking the missing values in the data set. So we upload the data set or training data set, and let's check how are we doing with the missing values. So we see that there is not so many missing values. I mean, we have maybe 600 missing values, but still lots of models will not work with missing values, or they might give you some strange results. So of course, the first thing that might to come to mind is to delete all this data that have the missing values. But that's a very dangerous approach, because of course the missing data are in all sorts of for different, I mean, see, for in different columns. So we might lose, basically the worst case scenario, we could sum up these, and this would be over, we could lose over 100 pieces of different data. So what can we do? I mean, so there is lots of ways how we can input the missing data. Basically, this is already first step, or first kind of you're already creating some model here at this point, right? So because you are already guessing, or what what is best to do with the data. So this is like some already your first tiny model. So like I said, we could delete them all, but that's dangerous, and usually it's not a good idea, unless there was one or two. I mean, yeah, then it would be I guess perfectly fine. So the simplest thing is to replace the missing data with their mean. So if we have a loan amount, we have 22 missing. There is another 600 that we have. So let's take a mean of those and change them for the mean. That will not skew the mean much, and therefore that seems like a good model to go with. But that's, let's say, one of the basic thing. Or what we could do is we could actually create a learning model to predict this based on other variables. So that could be already, we could here, before building our own model that answers the question whether you give or whether you get the loan or you don't get the loan, we could build a possibly smaller model, more basic model, that based on the other data that we have, predicts what should be your loan amount, and what should be whether the person is or is not self-employed based on the other data. But yeah, so that is task basically on itself, data analysis task. So definitely, if you're doing some serious subject, this is a possible way to go. But so here what we do is we're gonna take the middle road, and we will create we will have a guess that the mean value, for example, for the loan amount, differs depending whether you are self-employed or educated. and this combination of whether you're educated and self-employed or non-educated and not self-employed, that this plays a big role, and therefore it would be good to the missing value uh, replaced by the mean based on this information. So let's take a look here if such trend exists. So we draw a box plot. We already know how to do a box plot. And so we see here, yeah, that the mean kind of varies. So if you're a graduate and not self-employed, your mean value salary is less definitely than when you're graduate and self-employed. I mean, that's a known thing. If you make your own business, then uh, on average, you're gonna have much better salary than just being an employee. Similarly, it is known that if you're not a graduate, then your salary in mean will be lower, and uh, there is the same trend if you're employed or if you are self-employed. There is a skew, there is a difference between the salaries. So that seems that the medians are different. It makes sense to use that, to use this data to refill the missing loan amount. But first, we should check if we don't have any missing data in the self-employed and in the education. So if we go take a look back, self-employed, we missed 32, and loan amount. I'm sorry, education. Okay, education has no missing data, but self-employed is missing 32, is missing 32 values. So we have to first fix this. Well, how do we fix this? Well, let us take a look at the frequency table. And we see that in the frequency table, it tells us that from the data on self-employment, we have 85% people, or almost 86% people, is not self-employed, and only 14% people are self-employed in this data set. So it seems very safe to uh, change the missing values into the no value, right? I mean, the occurrence is so high, 86%. So yeah, so out of the missing values, 86% of them is no, only 40% is yes. I mean, that's the trend that we observed here in the much bigger data set. So that's what we're going to do. So we're going to use this function, fill the not available data, and so we put no whenever there is a missing data, and here we use again this in place equals true, so that means we are doing it in the data file. So we are changing the data file. All right, and so now we're going to go back, and now we want to do the to change the loan to change the loan amount with its mean. And so how we're going to do it? So first we're going to create a pivot table for which gives us the median for self-employed and education. So let me run the whole code and explain here. So now we've got the pivot table, right? So we know that the mean for if you're graduate and not self-employed is 130. If you're graduate and are you self-employed is 157, and so on. And now what this we want to impute this data into our data file, right? So first we're going to create this function. Here is called fetch, that gives back the values from this table based on uh, based on what your data have. So here this x, so that's one bit of a disappointment. One of the maybe sometimes a difficulty of the Python, right? So here you put so we define function fetch, and the variable is x, and here you have no idea. I mean, x can stand here for anything. You can put there input there anything, and you don't know a priori what the variable will be. So we have to take a look at this here, and so it should return table log. So all right, we know, so our table is again a data file, a log function. It uses the it it uses the names or the labels of the rows and columns, and so the first label will be x of self-employed and the other label will be x of education. So at this point, so we should realize, okay, so where are we going to use this function? How are we going to use this function? Is this function, this x, that's going to be the row of the data in your table. So we're going to give it the row, and then depending in that row what is the value of self-employed and what is the value of education, it's going to go and get the right number, the right median from this pivot table here. So that's what we see here. So we work with the df with the column loan amount. We want to fill the not available guys. So what we take is we want the df data where loan amount is null. So this here, this code, this piece of code takes the row of the data which has no it takes the row of the data where the loan amount is not available, and then we apply this fetch function. So that means it uses the uh, it grabs into this table, into our pivot table, and depending on in that row whether you are self-employed or educated, it's going to choose the mean, and of course it does it across the axis one, and we again it's in place true, so we're going to choose it inside of the we're going to change the data file. All right, so our next step is to treat the extreme values in the distribution of loan amount and applicant income. So let's start with the loan amount. So if we check it out again, so we remember, so we see that we have some real outliers, some really extreme loans. But on the other hand, it makes it it, it makes sense, right? That there will be a few people who, if they have a really good, if they have a good income, they already own some property, that they would go with some big project. So definitely, this does not sound like some error necessarily. So, uh, but anyway, having the data like this is generally not good for the model. So instead of changing this data or getting rid of them somehow, what we do is we transform them. So we transform them using the logarithm function, right? So the logarithm function, it's an increasing function, but as it increases, it slows down. So that means that it gives less significance to the very high values than it gives to our lower values. So how we can do that? Well, we create a new series. We just use the NumPy logarithm. We take a logarithm of the amount and add this series to our data file. So now we take a look at the distribution of the logarithm of the loan amount, and we see that this looks pretty much like the normal distribution, and so the effect of these outliers here is diminished basically. And so just to take a look, so now we see that we have a loan amount and we also have a loan amount logarithmic, right? So the next one is the applicant income. So if we take a look at the applicant income, here again, here we have some extreme values, and again it's really a question if they are uh, it could be it's possible, uh, but at the same time maybe this is not what is that important, right? The applicant income, that some people like here, they might not have really good income, but they might have a strong co-applicant income. After all, when you ask for the loan, if you can have a co-applicant, like your wife or husband, and so it's much better probably to take a look at those incomes combined together. So that's what we're gonna do is, so we take the applicant income, sum it up with the co-applicant income, and again, because here then we might have this, I mean, these extreme values will stay there, right? So again, it would be good to take a logarithm of this data, and if we take a look at the final result, so we see again distribution similar to this one here that is much closer to the normal distribution. All right, so these are the possible ways how to deal with these. At this point, we could also ask ourselves, I would say, quite important question. So we filled in the missing data based on the using the means, right? And in the means, we used the the raw data where there we had the extreme these extreme points, these outliers, and we know that mean is skewed by outliers. So yeah, so now it's an interesting question. You could ask yourself, what is better, if to first impute the missing data and then treat the outliers, or first treat the outliers and or impute the missing data? So you can try to think about it, maybe take a try to find some answers for that, to see some opinions of people, what they do, what they don't do, and why not. And so then the last thing that is missing now is we still have we still have missing values. So we fixed uh, the missing values in self-employed and loan amount. So it's up to you to fix the gender, married, dependents, loan amount term, and credit history. So I leave it to you, following the ideas we have seen here. Uh, you can think about it, how you would fix those for the next time. All right. But again, this is not your homework. This is just some kind of ideas how we should proceed. I'm going to show you next time how we proceed with this. And so this should give you the idea how to treat how to do the data managing on your own data set. But again, this is the work for the next week. In this week, you should be working on the exploratory exploratory analysis. All right. Thank you.